and specifically what's known as the sign test. And so kind of the goal here is, all semester we've been kind of really relying on the normality assumption, either because we're sampling from a normal distribution, or if we weren't, we could still move forward as long as my sample size was 30 or bigger. We could move forward even without normality, because the central limit theorem would give us normality. But many times, you might have a small sample size and you're sampling from a non-normal distribution. Can you still do any sort of statistical inference? And the answer is yeah, using non-parametric statistics. And so kind of where we're going is, so we have a population where the population median is some value Q sub 2, okay? And we get a sample from that population. And what we really want to test is, hey, is the median equal to some value, or is the median greater than some value? Okay? And we're going to do this at some significance level, say 0.05. And what's kind of cool here is this. If the median is Q2 sub 0, some value, when I collect the data from that population, about half my data points should be less than the median and half the data points should be about greater than the median. Would you guys agree? Okay. Because the median splits the data set in half essentially. So if I get a random sample from that population, approximately half my data points should be less than the median and half my data points should be greater than the median. Okay. So if I count the number of data points that fall above this specific median value I'm testing, then you would say, hey, I have n trials, a success is falling above the median, and therefore my random variable would have a binomial distribution, our old friend, the binomial distribution. And what we're going to do is we're going to exploit this fact to develop a test without relying on normality like we have in the past. So let's do this. So exploiting this binomial fact, exploiting this fact, we can do the test as follows. Okay. So my first step in doing a test is to get my test statistic. Okay. And I'm going to call my test statistic, I'm going to call it X star. I'm kind of using my own notation here. If you look at the sign test in the book, it's a little bit loose how they do it, and I think it makes it a little bit confusing. So when I wrote these notes, I think like last year or something, I tried to come up with a more rigid framework by which we can kind of work. So this is kind of Professor Matt's approach here, and so what we're going to do is let's let my test stat X star be n plus, and n plus we're going to define as the number of data points above my hypothesized value Q2 under the null hypothesis. Okay. So I'm going to count the number of data points above that hypothesized median Q2 sub 0. Okay. That's my test statistic. And from my test statistic, we're just going to jump straight to a p-value. And my p-value is going to be the probability that x is greater than or equal to x star, where x, like we said, has a binomial distribution, where n and probability of success is 1/2. Okay. And we can do our decision and final conclusion. So we're just going to exploit the little fact that, hey, the number of data points that fall above that hypothesized median should have a binomial distribution, right? Where my sample size is n, and my probability of success under the null hypothesis should be 1/2. And we're going to exploit that, and we can find our test statistic and p-value from that guy. So let's do an example so we can kind of see how this kind of plays out. So for example, the population median survival time in weeks for people with non-Hodgkin's lymphoma is some value, let's call it Q sub 2. Okay. Now, for all of the people with non-Hodgkin's lymphoma, the median survival time is going to be Q2. Okay. Now, I don't have data on everybody with non-Hodgkin's lymphoma, so what we're going to do is we're going to get a sample, okay, and we're going to do inference for that median based upon the data in my sample. So let's randomly select 10 people with non-Hodgkin's lymphoma. Okay. Here's the survival times. So the first person survived for 49 weeks, next person for 58, 75, 110, 112, 132, 151, 276, 281, and 362 plus. Okay. Okay, so this is the number of weeks that these patients survive with non-Hodgkin's lymphoma. The last data point, 362 plus, that's kind of known as a censored data point. And that last patient survived for 362 weeks, okay? The study ended, but the person was still alive, okay? So I don't know technically how long that person lived. It was at least 362 weeks, okay? Could be because they simply did not pass away during the course of the study. Does that kind of make sense? Okay. Now, if we had a data point like that with our old methods, would that give us some consternation as far as what to do with that guy? Yeah. But when you do non-parametric statistics, we can actually deal with data points like that just fine. Okay. So it's kind of a nice advantage. Okay. Now, here's what we want to do. Hey, let's test the population median survival time is 100 weeks. This is my null hypothesis, versus the alternative that my population mean survival time is greater than 100 weeks. Okay. And let's test this at the alpha is equal to 0.05 significance level. Okay. Okay, now, let me just try and argue this to you a little bit. Suppose I was testing 120 versus not 120. Okay, 120 is kind of at the tip of my pen. Okay, could if I was testing 120 versus not 120 for the median, I got half my data points below 120 and half my data points above 120. Does 120 seem pretty consistent with the median? Seems consistent. Would you reject the null hypothesis there? I would not. Okay. What if I was testing how about this? What if I'm testing 111 versus greater than 111? You would say, if the median was 111, I should get about half my data points less than 111 and about half my data points more than 111. Does my data set seem relatively reasonable with a median of 111? Is 111 a plausible value for that median? Sure, I think so. Okay. Now, where are we? We're actually down here at 100, okay? And so we're here at 100. If the median was 100, I would expect about half my data less than 100 and about half my data more than 100. Are you starting to get slightly nervous about 100 being the median? Slightly, okay? Are we nervous enough to start rejecting the null hypothesis or not? That's the question, okay? And so let's go through and we'll do the test and we'll actually figure out, hey, is 100 a plausible value for the median or not, okay? It's a little bit of a gray area if you kind of look at it naively, okay? So to do this guy, what we're going to do is let's kind of set up the test that as Matt proposed. So here's my test statistic, which is X star. And so for greater than, what we're going to do is we're going to count the number of data points. We're going to do n plus, which is the number of data points that fall above my median of 100. Okay? So n plus is going to be the number of data points that fall above the median of 100. Well, I have 10 data points. How many of my data points fall above 100? 1, 2, 3, 4, 5, 6, 7 of those guys. Okay? My test statistic here is 7. Beautiful. Okay? So if your alternative is greater than, what you're going to do is you're going to count the number of data points that fall above your median, which kind of makes sense. Okay, 2. Now, my p-value, I said it's going to be the probability x is greater than or equal to x star, okay? Where x, in this case, has a binomial distribution where n is equal to 10 and p is equal to 1/2, where x is the number of data points greater than 100. Okay. So what we have to find here is, I have to find the probability that a binomial distribution with 10 and 1/2 is greater than or equal to 7. Okay. No problem. X has a binomial distribution. Can you find the probability x is greater or equal to 7? Of course. And so the way we would do this kind of brute force would be, we would find the probability x equals 7 plus the probability x equals 8 plus the probability x equals 9 plus the probability x equals 10. Okay, no problem. And now this is really stretching your brain. Do you guys remember how to find a binomial probability? Yeah. If you guys remember, you're like a budding statistician. That's good. If you recall, it was just let me do it up here. It was n choose x times p to the x times 1 minus p to the n minus x power, right? Okay. And so every one of these probabilities I will compute using our binomial formula, where n is 10, p is 1/2, here x is 7. So what you're going to get is, it's going to be 10 choose 7 times 1/2 to the 7th power, 1 minus 1/2 to the 10 minus 7th power, plus all the way down the line. You can get those other guys similarly. Okay. And do we really want to do this by hand? That doesn't seem too fun. You think we could bust out something on the internet for? Yeah, okay. And so let's bust out Matt's app here, and let's go to the binomial. Remember, n is 10, p is 1/2 or 0.5. And we want the area greater than or equal to 7, or the probabilities from 7 bigger. So I'll do 7 and then greater than or equal to. And so I'm finding the probability x is 7 plus 8 plus 9 plus 10. What does that poop out for you? My p-value is equal to 0.171. Okay. So beautiful. So my p-value is 0.171. Okay. Got my test stat, I got my p-value. What's the decision now? Alpha is 0.05. My p-value is actually greater than alpha, so do I reject the null hypothesis or not? Do not reject HO. Okay? So do not reject HO. Which means that we simply have no evidence that the median exceeds 100. And you got it. If you saw this in the literature, what they might say is the median significantly greater than 100 or not? The answer is, it's not. Okay. So yeah, it looks like the median survival time is not significantly higher than 100. Okay. Does that kind of make sense, you guys? Okay. Yeah. So that's how you would do a test if your alternative was greater than. Let me show you how you would do a test if your alternative is less than. Okay. So let's try this. So let's try. So B. Let's test the null hypothesis that the population median is 300 versus the alternative that the population median is less than 300. Alpha is 0.05. Okay. Here's 300 right here. Now, what would you guys say here? If the median was 300, I would get about half my data points less than 300 and about half my data points more than 300. Okay. Are you starting to feel nervous that 300 is my median? Yeah, I am in this case, okay? In fact, it's so lopsided, I don't think my median in all likelihood is 300 because I would have seen closer to 50-50 above and below the median. I have 9 below the median and 1 above the median, so it's really lopsided. As such, do you think the median is less than 300 just looking at this? Do you think I'm going to reject the null hypothesis? I think so, okay? So let's do it. So step 1, we'll get my test statistic. And let's just call it X star. Okay. Now, when my alternative was greater than, we counted the number of points above the median. Okay? When my alternative is less than, I'm going to count the number of points that fall below the median. Is that okay? Okay. I'm going to count the number of points that fall below the median. And let's just call that n minus. That's the number of data points that fall below the hypothesized median. Okay. Well, the hypothesized median is 300, which is right here. How many data points do I have less than 300? I have 9 data points. So my test statistic here is 9. Okay. Okay, that's my test stat. How about our p-value? Our p-value is going to be the probability. Now, there was actually 2 ways I could lay this out for you guys. Each way had a drawback to it. Okay. The drawback in my chosen setup is this. If you look at the alternative is less than. And up until now, what would you use in your p-value? In your p-value, what inequality would you use there for? Yes. Less than. Okay. However, in the current situation, we're going to do greater than. Okay. Just trust me on this. There was one other way I could approach this whole problem, and that had a drawback too, and it was kind of the lesser of 2 evils. So just use greater than or equal to here. Little x star. Okay. So little x star is 9. So it's the probability x is greater than or equal to 9. where again, where x is a binomial distribution, n is 10, p is 1/2. And can I find the probability x is 9 or bigger here? Yeah, totally, right? And so what I have to do is find the probability x equals 9 plus the probability x equals 10, right? And for each of those guys, you could use the binomial formula. You could crank it out. Let's just use the app to get this really easy for us. Let's see what we get. So let's put in 9 for x and greater than. Okay, so the probability x is 9 plus the probability x is 10 is 0.0107. Okay, 0.0107. So this guy is 0.0107 for my p-value. Okay. Do I reject or not in this case? Yeah, is alpha's 0.05? Is my p-value less than alpha? Totally is. Do I reject therefore? We're going to reject, of course. Good. So we're going to reject the null hypothesis. What does that mean for the current situation? Do I have evidence that the population median is less than 300? The answer is yeah, I do. Okay. So we have evidence that the population median is less than 300. Okay. Which kind of makes sense, because if my median's 300, you should get about half your data below that and half your data above that. But 9 out of 10 of my data points fell below 300. Okay. So, yeah. Okay. So, in this case, my p-value doesn't match the alternative. You're kind of stuck with a little niggle like that. No matter how you set this up, it's just kind of the way it is. Do you think we can do a two-sided test? Yeah, we can do a two-sided test here actually as well. Okay. So let's try this. C. Let's test the null hypothesis that the population median is 350 versus the alternative, the population median is not equal to 350. Alpha's 0.05. Okay. Now, 350's out here, okay? Yeah, 350's between those two guys again. Now, here's the big question. If the median was 350, about half my data should fall less than 350 and about half my data greater than 350. Am I seeing such behavior here? I'm not. You think I'm going to reject the null hypothesis therefore? Probably, okay? Yeah, I agree with you. And so, okay, so to do this guy, we'll get our test statistic. So X star. Okay, now, for a two-sided test, you might say, okay, how do you find your test statistic? Okay, and this is something that comes up once in a while in statistics. What I'm going to tell you to do is, let's take the maximum of n minus and n plus. I'm going to take the bigger of those two guys. Okay, where n minus is the number of data points less than 350. So what is n minus? It's the number of data points less than 350, which of course is 9. And n plus is the number of data points greater than 350, which of course is 1. And if you take the maximum of 9 and 1, what do you get? 9. Okay. Okay, is that okay, you guys? Right? Okay, 2. You guys tell me how to find the p-value. How would you find
find the p-value here. Look at my alternative. Is it a one-sided alternative or two-sided alternative? 2. Okay. Do you think I just take a probability or twice a probability? Twice, and I totally agree with you. Okay, we're going to take twice a probability that x is greater than or equal to x star. Notice I actually don't need absolute value here because we're actually counting. My accounts cannot be negative, right? So you actually don't need absolute value at all. Which looks kind of similar to what we've done before. Okay? So remember, x still has that binomial distribution, and so I really have to take the twice the probability that x is greater than or equal to 9. And we just found the probability x is greater or equal to 9 above, right? We just found that guy. And so it's really twice this guy right here. So it's going to be 2 times 0.0107, which gives us 0.0214 for your p-value. Isn't that cute? All right? Okay. And so, okay, tell me what to do. We have the p-value. Is my p-value less than alpha? Of course. What do we do again? We're going to reject the null hypothesis. Yeah, good. Okay, so we're going to reject the null hypothesis. And again, we have evidence that the population median is not equal to 350. Okay. And that is known as a sign test. That's all it is. Okay. But you will notice, did we make any distributional assumptions about what the distribution that my data are coming from? No, not at all. Okay. So if my population has a skewed distribution, could I still do a sign test on that guy? No problem. Okay. And so you can do this for any population distribution that you want, because there's no reliance on the underlying distribution. We're simply counting essentially. Okay. And in the area of non-parametric statistics, you do a lot of counting. That's really kind of what it comes down to. Now, you'll notice that we're not doing the same test as what we did before, though, right? I mean, before we did a test for mu, a population mean. Now we're doing a test for a population median. Okay, it's not the same test, except for the case where if the distribution that I'm sampling from, if it's symmetric, the mean and median would both fall in the same place. So if my population was symmetric, the mean and median are the same, and these tests would be equivalent to mu is 350 versus mu is not 350, only if your population distribution was symmetric. Okay? But for any distribution that's skewed, the mean and median are not the same, and this is the only route that you have is to do a test for the median. So it's not a magic pill here, but it gives you something to kind of move forward and do inference. Okay. You guys want to try one more? Yeah. Why don't we try one more? So let's try this. So let's look at cholesterol levels. Of 10-year-old kids. As a distribution that is skewed to the right with population median Q2. So we're looking at the cholesterol level of 10-year-old kids, and it's skewed to the right. So most kids have a reasonable cholesterol, but there's a few that are higher for whatever reason. Okay. And we're assuming that the population median is some value Q2. And so let's randomly select 12 kids. Here's what we found. So let me just give you the cholesterol. 154, 139, 194, 145, 133, 172, 135, 149, 142, 150, 186, 155. Okay. So there's the cholesterols for those 12 kids. Now, just really naively looking at this, do you think the median cholesterol is 200? Is the median cholesterol 200? Definitely not. Okay, you would reject. Okay. Is the median cholesterol 100? Definitely not. Right, you would reject. Okay. How about this? Is it 180 versus less than 180? So let's test the null hypothesis that the median cholesterol, Q2, is 180, versus the alternative, Q2 is less than 180. Okay? Alpha's 0.05. Okay, let's test that baby. Oh, but before I forget to tell you guys, what if, as I'm counting, what if one of my data points equaled 180? Throw it out. Okay? So if one of your data points equaled 180, I'm not sure if I would put it less than or greater than. Just throw that guy out. Okay? Okay, so for this test, what is my test statistic, you guys? Now think to yourself, X star, it's what? I'm going to count the number of data values above or below the median. Remember, when I have less than, I'm going to count the number of data values below the median. Okay, so we're going to do n minus. Okay, count that. So what is my test statistic in this case? It's the number of data points that are less than 180. Let me count two. I think my test stat's 10. Do you guys agree? Okay. Okay, so under the null hypothesis, if the mean is 180, I expect about half my data points to be less than median and half greater than. So under the null hypothesis, the number of data points less than 180 should have a binomial distribution. N is 12, P is a half. So 2. What's my p-value? Yeah, for my p-value, do I have a one or two-sided alternative? Yeah, we have a one-sided alternative, and so it's going to be my p-value. It's going to be the probability that x, which is that binomial distribution. Now, this is the one case that's a pain in the butt for you guys. What inequality do I put on my p-value in this case? Less than or greater than? Greater than. Okay, so it's not going to match the alternative. Okay, so the probability x is greater than or equal to x star. So it's the probability that binomial is greater than or equal to 10. Well, x has a binomial distribution where n is 12, p is a half. Can I find the probability x is greater than or equal to 10? No problem. And so you would take the probability x is 10 plus the probability x is 11 plus the probability x is 12. And you can use the binomial formula, punch us in. Let's just use the magic of TV here, and we can get this guy really quick. And so I'll put in 10 here, and n is 12, and my p-value is 0.019. So 0.019 is my p-value. And what's my decision and final conclusion therefore? Am I going to reject the null hypothesis, of course? Totally. And does it look like the median is less than 180? Totally does. Yeah, so we're going to reject HO. And we have evidence that the median is less than 180. Beautiful. Okay. Or equivalently, the population median is significantly less than 180. Okay. Could you guys do that on the exam? That's not too bad, right? Okay. Why don't we try the greater then? Just to make sure we're totally on the same page here. Let's test. The null hypothesis that the population median is 140. Versus the alternative, the median is greater than 140. Alpha is 0.05. Okay. What is my test statistic in this scenario? Is it n minus or n plus? N plus, okay? So n plus, the number above 140. And so let's count. Under the null hypothesis, I should get about half less than 140 and half greater than 140. How many did I actually see more than 140? Let me count with you. 1, 2, 3, 4, 5, 6, 7, 8, 9, I think. Okay. Okay, 9 data points more than 140. Good. Okay, that's my test statistic. My p-value is going to be the probability x is greater than or equal to 9. And so let's find that guy. And you can do this by hand. You take the probability x is 9 plus 10 plus 11 plus 12. And so put in 9 here. And the probability that x is 9, 10, 11, and 12 is 0.073. Okay. So 0.073. And tell me what I'm going to do. Reject or not? Do not reject HO. Good. Good. So do not reject HO. And therefore, we have no evidence that the population median is greater than 140. Okay. In other words, if the null hypothesis was true, would it be possible I would see 9 data points above the median and 3 data points below the median? That's possible under the null hypothesis. That's kind of what that's saying. Okay. On part A, if the null hypothesis was true, is it possible that I would see 10 data points below the median and 2 data points above the median? According to the test, that really should not be. It's very unlikely under the null hypothesis, and in that case, we rejected the null hypothesis. Okay, you guys try the two-sided test. Okay, and let's do the following one. Let's test the null hypothesis that the population median is 160 versus the alternative, the population median is not 160. Alpha is 0.05. Try that guy. Okay, now this is the one with a little bit funky test statistic. What was my test statistic, you remember? Was it n minus? No. Was it n plus? No. What was it? It was the maximum of n minus and n plus. Okay. It's the bigger of n minus and n plus. Okay. What are those guys? What is n minus? N minus is a number of data points less than 160. Let's see what we get. Nine? Is that right? Okay, 9, okay. So it's the maximum of 9, and n plus is the number of data points above 160, which of course is going to turn out to be 3. Good. And you take the maximum of those two guys, which gives you 9, and 2, my p-value. Now be careful, we have a two-sided alternative, so what's my p-value going to be? Twice the probability. Yeah, so it's going to be twice the probability that x is greater than or equal to x star. So it's twice the probability x is greater than or equal to 9, which actually is twice 0.073. We actually found that just a second ago, which is 0.146. P-value is greater than alpha, so what do? Don't reject each other. Is it reasonably likely, if the median was 160, is it reasonably likely that 9 of the data points fall below the median and 3 fall above? That's reasonably likely, so we don't reject the null hypothesis. Okay. What do you guys, you guys like my setup for this thing? Yeah, I scratched my head quite a bit. There's 2 ways you could do it. The one bad thing with my way is on the less than test, the p-value doesn't kind of match that. That's the one drawback to doing it this way. If we do it the other way, I was thinking of, there's another drawback. So there's kind of no free lunch here, so it's just kind of the way it is. If you read this in a textbook, the textbook is kind of it's kind of loose as far as how the test is set up. I think it's a little bit better to have it a little more structured like this. So a couple things. Tomorrow, I won't be able to have office hours tomorrow. I emailed you guys, but I will have office hours on Friday from 11 to noon. Okay. The final exam